Hello everyone, here I will introduce our paper ResFormer Scaling ViTs with Multi-Resolution Training. The paper is accomplished by researchers from Fudan University and Microsoft Research Asia. To begin with, let me introduce a brief summary of our work. We propose ResFormer, a framework that is built upon the seminal idea of multi-resolution training for improved performance on a wide spectrum of mostly unseen testing resolutions. In particular, ResFormer operates on replicated images of different resolutions and enforces a scale-consistent loss to engage interactive information across different scales. More importantly, to alternate among varying resolutions effectively, we propose a global local positional embedding strategy. Vision transformers build upon the multi-head self-attention mechanism for feature learning by partitioning input images into patches of identical size and processing them as sequences. In image classification, the de facto training of ViTs commonly adopts a resolution of 224. To test or fine-tune pre-trained ViTs on resolutions different from the training one, a common practice is to keep the patch size fixed and then perform bicubic interpolation on positional embeddings directly to the corresponding scale. In the meanwhile, scaling down the input scale of ViTs is a popular strategy for reducing computational costs, while scaling up the resolution is widely used to produce better results and transfers where to dense prediction tasks, such as object detection and semantic segmentation. We explore the resolution generalization of ViTs by following the common interpolation strategy and testing ViTs on a wide spectrum of resolutions. As shown in the figure, ViTs are vulnerable to resolution discrepancies during training and testing. Performance drops sharply when directly adapted to small-scale inputs and is also unsatisfactory when input scales enlarge. However, we wonder how to gain advantages of both low and high input resolutions. To this end, we introduce ResFormer, which scales ViTs towards a wide range of testing resolutions so as to meet the need for versatile applications. In general, as depicted in the overview figure, ResFormer is built upon two key design strategies, that is, multi-resolution training and the global local positional embedding. Considering multi-resolution training, ResFormer takes inputs of different resolutions during training so as to better model objects of varying sizes in different scales and generalize better during inference. In specific, we replicate a given training image for R times, where R denotes the number of resolution used. For the ICE data replica Xi, we use the class token output of the last transformer block into classification head to compute the final predictions Yi. Then the cross entropy loss is computed based on Yi and the ground truth label T. Given that the larger inputs generally produce better recognition results compared to their smaller counterparts, we take advantage of knowledge distillation through enforcing consistencies among different resolutions, with a small L1 loss with feature whitening to transfer knowledge from the class token of a higher resolution to that of a lower one. Furthermore, we propose a global local positional embedding strategy to bridge the resolution gap among a broad range of scales. The global and local positional embeddings change smoothly conditioned on input sizes to alternate among varying resolutions effectively, especially novel ones in testing. The global positional embedding is composed of a sinusoidal positional embedding followed by a one-layer depthwise convolution. We incorporate local positional embeddings into the multi-head self-attention blocks. Specifically, we inject value of each head into a 3 times 3 depthwise convolution. As a result, compared with vanilla ViTs, ResFormer demonstrates superior performance over a wide scope of resolutions. On one hand, ResFormer outperforms models trained with single-scale input with clear margins on all scene resolution. On the other hand, ResFormer demonstrates clear scaling capabilities for unseen resolutions. Specifically, when evaluated with a testing resolution of 224, ResFormer Small MR and ResFormer Base MR offers an accuracy of 82.16% and 82.72%, respectively, outperforming their DEIT counterparts by 2.33% and 0.93%. Given a testing resolution of 384, ResFormer's More 224 achieves a top 1 accuracy of 80.65%, which is 2.55% higher than its DIT's More counterpart. By aid of multi-resolution training, ResFormer's More MR further boosts the accuracy to 82.72%. We also demonstrate that ResFormer can be easily and effectively adapted to downstream tasks, such as semantic segmentation, object detection, and video classification. As shown in the table, ResFormer MR achieves promising performance on dense prediction tasks. Thanks you for listening.